We're moving on to probability. There's two probability chapters, one in this book, one in the next book. And the last chapter of statistics that we did, it wasn't that difficult, and there wasn't as many questions as the previous chapter, because obviously it was a bit easier. Now this one I'll expect way more questions, because probability is one of the ones where people will finish it, get the answer, think it was relatively easy. But when you go and check your answer in the back of the book, and it's vital for this chapter you check your answer in the back of the book, because it's not going to be as obvious as like if you know in certain other things you know it works out. And then you ask the question if you can't get it, because in an exam I'll have plenty of times people come out to me and say, oh, probability was easy, and then I'll correct it and it was terrible. Okay, so it's the double today, so we're going to be permutations, but we're going to do this tomorrow because there's quite a lot in this. Alright, so we're going to start off permutations. So fundamental principle accounting, so we did this back in first year. Fundamental principle of counting even. If one task can be accomplished in one amount of ways, and the following second in another ways, n, to find the total combinations, you just do n by n. And that's really seen in an easy example. I'm not going to go through or do anything. We did this, I think, with starters, main courses, desserts in first year or second year. If we have 6 first names, and we have 5 surnames, and we want how many different combinations, instead of going Mary Mooney, Mary Byrne, Mary O'Brien, Mary Lewowski, Mary McCarthy, Jennifer Mooney, Jennifer Byrne, Jennifer O'Brien, which we could possibly do if we were asked to write out the actual combinations. If you're asked how many different pairs is there, you literally just do there's 6 here, there's 5 here, it's 30. If there was a middle name in there and say there was 4 middle names, it would be 6 by 4 by 5. Okay, it's very, very simple. Alright, so just make sure you know what the fundamental principle of counting is and how to use it. That's first year stuff, second year stuff. Permutations is slightly trickier in terms of what we're going to do. It's how many ways can things be arranged? And instead of listing off, because once you go past a certain number, it doesn't make sense to list off. So if we have the letters A, B, C, how many different ways can they be written if none are repeated? A, B, C, A, C, B, B, C, C, and so on. There's 6 ways. Each arrangement is called a permutation. So there's 6 different possible permutations. When calculating this, it's sometimes good to use boxes, which I'll show you in the examples I'm going to do. So if we have 3 letters, there's 3 different boxes, 3 different outcomes. What they do here is they say, how many ways can the first box be filled? It can be filled in 3 different ways, A, B, or C. Once you've picked one of them, how many letters are left? 2. And how many different letters are there at the end? Just 1 left. So it's 3 by 2 by 1, which is 6. Factorial notation. Now you're going to see this as using it as a shortcut. Factorial notation is when we use this exclamation mark. If we ever want to write 3 by 2 by 1 or do it on our calculators, we can say 3 factorial. If we have 8 factorial. And where does this save us time? If we have 50 and we want to write 50 factorial. Okay, and how do we find that in our calculator? So the factorial button is up here. Can you see it just above the x minus 1 button, x exclamation mark? So if we want to find 3 factorial, we press, first of all, on, 3 shift factorial, press equals 6 ways. 8 factorial, 8 shift factorial. There's over 40,000 ways 8 things can be rearranged, if they're all different. And again, you wouldn't do 50 by 49 by 48 by 40. 50 factorial, obviously a massive number. Okay, if you have 50 different things, the way they can be arranged is massive. Right. So I want to make sure that you know factorial notation. N factorial is the number of permutations of n different objects when all objects are included in each arrangement. Okay, when all are included. So I'll include this in our example, so don't worry if you don't fully understand it yet. We're going to go through example 2, 3 and 4, and then on Tuesday I'll go through 5 and 6. So there's a bit in this, but the questions are short. But again, I'm sure I'm going to get plenty of people going, sir, I don't know how they got the answer in the back of the book. And that's what I want, please do ask. So my first example is about books on a shelf. So there's 6 books on a shelf, including a science book. How many ways can they be ordered? So if you think about it, if there's 6 different things that have to be picked, there's 6 different books. I usually use boxes to represent each pick. So how many ways can the first box be filled? or first book be picked? It can be any of the 6, can't it? And then once we've picked the first book, there's only 5 left. And once we've picked the first 2 books, there's only 4 left. 3 left, 2 left. And when you've picked your first 5 books, you'll only have 1 left. There's only 1 way. So it's 6 by 5 by 4 by 3 by 2 by 1. And that is 720 ways. But if you don't want to type into your calculator 6 by 5 by 4 by 3 by 2, 1, or you don't even want to write 6 by 5 by 4, you can write 6 factorial, type that into your calculator, and you'll get 720 ways. Okay? Now, it's not always going to be as easy as that. You might get, if you're lucky, you might get the start of a question like that. There's going to be restrictions put on this, and I'll show you what I mean by restrictions. This second part tells us how many ways if the science book has to come first. So again, if I put out my 6 books here, my 6 boxes to represent the books, in the last part, 6, any of the 6 could go here, but in this part it has to be it has to be the science book. So there's only one way this box can be filled. And once I've used up that science book, I have 5 books left. It doesn't matter what the order is. So it can be 5, and again 4, 3, 2, 1. So in this case, it's 1 by 5 by 4 by 3 by 2 by 1 equals 120 ways. 120. That's not 30, it's 20. Rewrite it. 120 ways. Or if you were lazy, you could have just realised that's a 1, it's 5 factorial, and that would give you 120 ways as well. So there's 120 ways of rearranging that if the science book has to come first. So that's a nice, easy, I call them restrictions or rules that have to be followed if you ask them questions. So read the questions very carefully. This isn't probability, this is just working out the number of different ways. You'll use this, obviously, when you're working in probability later. The next thing, Scotland. Okay, so it says the letters of the word Scotland. First of all, we need to know how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8 letters. Okay? 8 letters. How many ways can they be rearranged in a line? So the first question asked how many rearranged can be rearranged in a line. It's just 8 factorial because they're all different. 8 by 7 by 6 by 5 by 4 by 3. And I think in the book they say that's 40,320 ways. So I'm more concentrated on the second one. So we'll read the example, but the second 2 parts. So they've listed them as part 1 or part 2. How many ways can be arranged if the vowels always are together? Now this is important. O is a vowel, A is a vowel. Get your English teacher onto that. How many ways can they be arranged if the vowels always are together? So they're always beside each other. So if I have 8 different letters, there's 8 different boxes. 1, 2, 3, 4, 5, 6, 7, 8. 8 different boxes. However, just say this one was A and this one was O randomly. Those 2 always have to stay together. The A and the O always have to stay together. So if the A moves, the O moves. So in fact, there's only 7 boxes there. 1, 2, 3, a big box, 4, 5, 6, 7. And this box can be anywhere, by the way. So it's actually 7 by 6 by 5 by 4 by 3 by 2 by 1. So that's 7 factorial is 5,040 ways. Now, not quite finished with that one. That O and A will always move together. Okay, it has to. However, within the A and the O, it can always be A, O, or it can be O, A. So there's 2 different ways that can be written. So you've got to multiply this by 2. Because say if we had I'll put O and A at the start. Say it was A, O, S, C, T, L, N, D. Another combination could be OA, SCT, LA, LND. So each of the combinations, there's 2 more. So if there's 2 things put together, that's the first box can be filled 2 ways, the second box 1 way, or 2 factorial, which is just 2. So multiply that by 2. And that is 10,080 ways. Okay, there's definitely going to be questions with that in it, and I'm sure I'm going to have to go through more examples of it. Right. How many ways begin with an S and end with the vowels together? Sorry, I just scribbled that out when I was... So they end with the two vowels and they start with an S. So I'll put out my 1, 2, 3, 4, 5, 6, 7, 8. The first one has to be the S. So there's only one way that can be filled. Has to start with the S. The last one has to be the AO or the OA. Okay, so this one acts as, this can only be filled one way, the AO or the OA, and we'll come back to that. We'll deal with that separately. So that means if two of them have been used, there's only 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. That's 5 factorial, which is equal to 120. However, again, as in the last part, the O and the A can be switched around to be A and O or O and A. So there's two ways. Again, the reason I'm showing you this instead of just multiplying it by 2 is because, say if there was 3 things together, it would be 3 by 2 by 1, which is actually 6. So 2 by 1, or 2 factorial, is equal to 2. So we multiply those, so there's 240 ways. Okay, last example. Alright. 0, 2, 5, 7, 8. So be very careful with this. So I haven't actually taken down the first part, I'm just going to do it now. It says, how many 4-digit numbers? So actually there's a part of that. How many 4-digit numbers can be made from those if no number is repeated? So again, I missed this part when I was rewriting the question. I've just noticed it now. So there's 4 different numbers from this, 4-digit numbers. If I was to say, I cannot have, now be careful with this, it's a common mistake. In a 4-digit number, what number cannot be the first number? It can't be 0, can it? Because if I have a 0 in a number at the start, I don't say 849 has a 0 at the start. So, however, if they ask for a PIN code or something like that, obviously 0 can be included. But in this case, only one of the first 4 numbers can be included. Sorry, one of these 4 numbers. So it's 1 of 4. Once I've used one of those, how many numbers are left? 4. So this one can be filled 4 ways. 3, 2. So I can't do 4 factorial if it doesn't go to the end. In this case I can because I'm only missing the 1. But I always just say do the 4 by 4 by 3 by 2. And that is equal to 96. 96 ways. Okay, now these are the actual questions I'm more concerned with. How many ways are the numbers greater than 5,000? So there's 4 of these 4-digit numbers. So there's 4-digit number. How many of them are greater than 5,000? To be greater than 5,000, the first number must be a 5, a 7, or an 8. It can't be the 2. And 0, we've said, can't be a first number of a 4-digit number, unless it's a PIN code or something like that, a code. So it can only be filled how many ways? 3. Once I've used one of those ways, either the 5, 7, or the 8, I don't use all 3 of them, I just say I use the 7. How many different ways can the next one be filled? 4. And once I've used 2 of them, say these 2, 3 and 2. So it's 3 by 4 by 3 by 2. And that is equal to multiplied equals 72 ways. And last example, I know this video is a bit longer, but it's the double, so you have plenty of time. The questions are not long, it's about understanding them and asking me if you're unsure. How many of the numbers are odd? Okay, so we still have our 4 boxes because it's a 4-digit number, it's not a 5-digit number. There's 2 boxes affected. The first box can only have 2, 5, 7 and 8, but also the last box can only have an odd number. Okay, so how many of them can go in there? It can only be I'll rule out this, the 5 or the 7. So this can be filled in two ways. It has to be an odd number. So say I use the 5. How many can go in the first box? Not 4, because one of them is a 0. Now, in certain cases, you will be able to use the 4. Only 3 of them. And now, once I've used, say, the 5 and the 2, this can be filled in 3 ways. Once I've used one more, this can be filled in 2 ways, and that's it. So it's 3 by 3, 3 by 3 by 2 by 2, and that is 36 ways. Sorry, 36 ways. Sorry if the camera work was a bit off there. So, this is about, please, try the questions. You have to check the answers. Don't say, oh, that question was easy, right? Because you could be totally wrong, like getting 0. There's not a lot of working out in these. So please, check your answer. If you can't get to that answer, ask me. It will take me really, really quick time to do some of the solutions to these. Alright? Remember, this is the double, so you've got an hour, 20 minutes to take this down, attempt the questions, ask me, and so on. Alright?